Alright, so in this tutorial we'll go over how to view atomic orbitals. And if you want to follow along, you can pull up problem number 1 in the first computational assignment. So really, in order to view an atomic orbital, the first thing we have to do is a calculation. If we do not do a calculation of some sort, then nothing's going to work. The calculation is just detailed in the methodology notes. And we will actually go over each one of these individually as we go over the calculation. Just keep in mind that these keywords are necessary in order to make the calculation run correctly. So if we open up Gauss view, again we get the tips box, which is usually not helpful. We see here on our main clipboard we have default methane, and we want to visualize the carbon ground state atomic orbital. Now, in order for us to get back to carbon, we're going to have to delete all these hydrogen atoms around it. So select carbon, select the delete atoms button. Whoops. Delete those hydrogen atoms, and now we have our carbon atom. The button we're going to be working with most of the time is the Gaussian calculation setup. That's under calculate, the first option. Now, as it says in the problem, we want to do an energy calculation. And fortunately for us, the first option on the job type tab is energy. I mean, there are other types of calculations we could run, but we will save those for another time. So here under the method, this is where the methodology comes in handy. So the method to get to this M062X, we'll just select custom under Hartree-Fock. This will just delete and type in M062X. And to get the 6-31G, we'll just select that under the basis set, and we want the D in the second space over. Now the charge, 0 because it's a neutral carbon atom. Triplet, or 3, just refers to the spin of the electrons we could see. It's possible to do other types of charges and spins for the carbon atom. That's just going to change the number of electrons that are available or not available, and which ones have a spin state and which ones do not. Also, it says to add the pop equals full keyword. So add that in really quick. Just type it in. Click update. Job title is optional, or title is optional. Click submit. Hit save. I'll just save it as atomic orbitals. Carbon. Save. Submit to Gaussian. Should only take a couple seconds, and it's done. Now, when we pull up the checkpoint file here, it's really not going to tell us much because it just shows us carbon. To view the atomic orbitals, we're going to go over to the main clipboard, and you want to click on this green red button, and that'll show you all the orbitals. Now, if we examine it right here, we see 6 electrons, and that makes sense because we gave it a charge of 0. Carbon has 6 protons, so in order for it to have a neutral charge, it has to have 6 electrons. Now, if we want to view each of these orbitals individually or together, we're going to want to click on them, or this is highlighting them, and yellow, I think, is just the default color. We'll go down to the Visualize tab. Just highlighted is already the option. There are other different types of orbitals you can view, but highlighted just makes it so you can look at specific ones. Just click on update like it just did a second ago. Takes a couple playing around with, but see, now that I've highlighted them, now I can view the different types of orbitals. This one right here is a p orbital, and I can zoom in, I can zoom out. Here we have the 1s, we have the 2s, that's the 2p, I believe. And that is how you view atomic orbitals in Gauss view.